Okay, this lesson is trig ratios part 2. In our first video, we learned about the three most common ratios, sine, cosine, and tangent, and how to write them and refer to them in a right triangle. Remember, we're continuing our discussion about right triangles and the relationship between the lengths of the sides. And now we're looking at sine, cosine, and tangent to explain the relationship between the acute angles, so either this angle or this angle in a right triangle. And where we stopped was right here. Okay, so what we have here is example 3. It says, let A be an acute angle in a right triangle. So here's our right triangle, A, B, and C. And we want to approximate the measure of angle A to the nearest degree. Okay, so here we're going in the opposite way. They're giving us the relationship between the sides, and they're asking us for the measure of the angle. Now, in the last video, let's see, let me put some measures here. Say that this was 3, 4, and 5. And so we said that the sine of angle A, we'll look at that one, is the length of the opposite over the hypotenuse. So in this triangle right here, the sine of A would be 4 over 5. Okay, and we expressed it as a fraction. Well, 4 divided by 5 can be put in your calculator and you can get a decimal answer for this ratio. So that's what these are. So this is just the ratio. It's being expressed as a decimal instead of a fraction. Okay, so now let's work the opposite way, and we're going to use our table. If you have a calculator, though, I'd like to show you how to do it in the calculator. So please let me know what calculator you're using. We're using the Inspires. So in this picture right here, we have the cosine of A. Okay, so the way we would write this is we would use what's called the inverse cosine, and it looks like that. It looks like the cosine raised to the power of -1, but it's called the inverse cosine of 0.3907, and then if you put that in your calculator, it will give you the angle, or we can use our table. So I'm going to scroll down, and remember cosine is, let's see, this middle column, and we're looking for 0.3907, and it is right here. Wait a minute. And so that is 67 degrees. So the cosine of 3907 is 67 degrees. Okay, so now we want to find the tangent, or the inverse tangent, of 8.1443. It's kind of hard to write over here on the side, but we're looking for the angle that is associated with the inverse tangent of 8.1443. So again, tangent is our last column. We scroll down, and we find that right here. And so that is 83 degrees. Okay, and then next we have the inverse sine of 0.6293. This one right here. Sine is our first column, 0.6293. There it is. So that is 39 degrees. There we go. I don't know why I have such a hard time with this, but scrolling back and forth, and then the inverse tangent of 0.3640. Last column right here, so that is 20 degrees. Okay, So you're just gonna just looking up the values there. So this one is 20 degrees. Okay, so now let's see, how do we use this? Okay, we know how to use our tables or the calculator, but now how's that going to help us? Okay, so let's look at example 4. So we have a triangle. Now they have to show you that it has to be a right triangle. Okay, and so we have a right triangle. We have an angle measure of 27. If you would like to use the other angle, which for some reason there may be a reason to, you can find it, because if we have 90 and 27, we can add those and get 117, and if we subtract from 180, this is 63. So we can use either the 27 degrees or the 63, and it's asking us to write an equation. Okay, so the first thing you want to do is, put this back here, 63 and 90. Just decide which angle you want to use. Okay, and so I'm going to use the 27 degree angle. Okay, so if I'm using the 27 degree angle, where is my x in relationship to that angle? Is it the opposite side, the adjacent side, or the hypotenuse? Okay, so in this, x is the opposite side. Now, they have to give us one measurement. Well, the measurement that they give us is 12. Well, 12 is my hypotenuse. So x is opposite, and the measure I have is the hypotenuse. So which of our trig functions uses opposite and hypotenuse? Well, that is sine. So when we write our equation, we're going to say the sine of some angle. Well, the sine of this angle right here. So our equation is the sine of 27 degrees, you don't have to put your degree symbol here, is equal to the opposite, which is x, over the hypotenuse, which is 12. That is your equation. So when asked for the equation, that would be the equation you write. Now we want to solve for x. Okay, if you have a calculator, this makes it a lot easier, but we can still use our tables to do this. This sine of 27 is just a number, and we're going to look it up in our table. Before we do that, I'm just going to tell you, we can write this over 1, and now we have a proportion. Okay, remember, proportions are two ratios that are equal to each other. So if we write this as a proportion, then we can just cross multiply, and we get 1 times x is x is equal to 12 times, and the sine of 27 is a number, okay? And please try and remember to put the 12 first, because sometimes, don't do this. I'm going to write it over here. Sometimes people write it like this. The sine of 27 times 12. Okay, that's not incorrect, but this should be in parentheses because this represents a number. And if not, some people get confused and they want to multiply 27 times 12. Okay, this is the sine of 27. So we're going to look that up. So this is x is equal to 12 times some number. And now we go to our table. What is the sine of 27? The sine of 27 is 0.4540. Point 4540. So now our answer is 12 times 0.4540. So let me see my calculator. Twelve times 0.4540 is 5.46. So there we go. So x is 5.46, and our equation was the sine of 27 is equal to x over 12. Okay, let's look at our next example, example 5. Okay, so again, you can use either angle, 21 or 69. So for example 5, I'm going to set this up 2 different ways just to show you. Okay, so if we're looking at 69, x is the adjacent side. And they give us the hypotenuse again. So that's cool. So we have the cosine of 69 is equal to adjacent x over 9. Or if we wanted to use 21, x is the opposite side. So this would be the sine of 21 is equal to x over 9. Either of these equations work, and both equations give you the same answer. So we'll look at it both ways. Okay, so let's look at the cosine first. We can go to our table, look up the cosine of 69 degrees. And it is 0.3584. Okay. So this is 0.3584 is equal to x over 9. We're going to cross multiply and we get x is equal to 9 times 0.3584. Usually I do it, it doesn't matter. Anyway, so 9 times 0.3584. And it is 3.23. We'll go over here, and again, usually I write it out as x is equal to 9 times the sine of 21 before I look it up. So x is equal to 9 times, and we'll look up the sine of 21. And that is 0.3584. And multiply 0.3584 times 9, and you'll see you also get x is equal to 3.23. Okay, so you can do it either way. Please pause and do the quick check. I'm running out of time on the video here, so I'm going to pause too. Okay, so here are the two different ways that we could have written that up. Let me just get a different color. If you use sine, okay, then we're looking at this angle here, 53, and so opposite over hypotenuse is x over 13. Or if you had used this angle here, x is adjacent, so we could have said the cosine of 37. Either way, you write the equation and then you cross multiply. Here we get x is equal to 13 times the sine of 53. On the other one we get x is equal to the 13 times the cosine of 53. If you look up the sine of 53 in your table, it's 0.7986. If you look up the cosine, it is 0.7986. So it's the same thing either way. You cross multiply and x is equal to 10.38. Okay? So let's look at one more type, and we're going to be working on these for a few more days. So this here is they're asking for x and y. And they give us this angle here, which is 54. And so 90 plus 54 is 144. So this angle would be 36. Okay, so when we're looking for x here, x is the hypotenuse. So it doesn't matter which angle we use. X is going to be in our denominator. So that is what is different on this one. So let me give us a little room here. I'm trying to erase this if I can. Okay. So we're going to say that I'm going to use, let's use the cosine of 54 equals 8 over x. Okay? So I'm using 54. 8 is the adjacent side, so I'm using cosine 8 over x. So I'm going to write this as a ratio. And when I cross multiply here, I get 8 is equal to x times the cosine of 54.